To obtain a power series representation for the function f of x, oftentimes we would need to use the basic geometric series or one of the well-known series that we covered in this class, such as e to the x, sine of x, cosine of x, tangent of x, ln of 1 minus x, and so on. Observe that the basic geometric series has the sum of 1 over 1 minus x, which can be represented as the series x to the n, assuming that the absolute value of x is less than 1, the radius of conversion is 1. If we hope to use the geometric series to write the power series for f of x, we need to rewrite it in the form of the geometric sum. That means that we can rewrite it at 48 over 4 plus x squared. And then we factor out the 4 so that we have the 1 in the denominator. Factor out the 4 in the denominator, we have 4 times 1 plus x squared over 4. 48 over 4 is 12. The denominator is now 1 plus x squared over 4. But the geometric sum is 1 over 1 minus r, or a over 1 minus r. And so we can rewrite this at 12 over 1 minus negative x squared over 4. And so this is the sum of the geometric series, assuming that the initial term is 12 and the ratio is negative x squared over 4. And obviously assuming that negative x squared over 4 is less than 1. Then we can write this as the sum of n go from 0 to infinity, 12 negative x squared over 4 to the n. This is the geometric series AR to the n, where a is 12 and r is negative x squared over 4. Simplifying this, we have the sum as n go from 0 to infinity, 12 times negative 1 to the n, x to the 2n over 4 to the n. This is the power series that represents the function 48 over x squared plus 4, which is f of x. Now we're going to integrate the series from 0 to 2 as the same as we did before when we integrate the function f of x from 0 to 2. But we can move the integral inside the summations so that we integrate 12 to the negative 1 to the n over 4 to the n x to the 2n dx. Now 12 times negative 1 to the n over 4 to the n is a constant because the variable of the integration is x dx. So we can move that to the front of the integral. The antiderivative of x to the 2n is x to the 2n plus 1 over 2n plus 1. And this is the definite integral. We evaluated from 0 to 2. Plugged in 2, we have the series 12 times negative 1 to the n over 4 to the n times 2 to the 2 to the n plus 1 over 2n plus 1. And plug in 0 into x. 0 times any constant is 0. Thus, the integral is now the infinite series. Simplifying this series by using algebraic manipulation, we end up with the infinite series at n go from 0 to infinity, negative 1 to the n times 24 over 2n plus 1. So the first 5 terms of this series is when n is 0, a sub 0 is 24. This is because we plug 0 into n. When n equals 1, we have negative 1 to the 1 times 24 over 2 times 1 plus 1, which is minus 24 over 3, which is 8. A sub 2 is positive. This is an alternating series, 24 over 5. A sub 3 is 24 over 7, but it is negative because negative 1 to the third power is negative. A sub 4 is positive now, 24 over 9. This is the first 5 terms, a sub 0, a sub 1, a sub 2, a sub 3, a sub 4 of this infinite series.